Okay, so hi everyone. So today we're going to complete the last three questions, okay, that have to do with specific heat capacity. Okay, and these are like essay questions that are always asked in paper 2, either section B or section C lah. Okay, so let's get down to it now. So diagram 9.1, okay, this is in your module. Diagram 9.1 shows two identical electric kettles. Okay, and P and Q, they are both filled with different quantities of water. So, when they are filled with different quantities of water, you know that they have a different mass. The mass is different already. Okay, now diagram 9.2 shows only kettle P that releases steam after 5 minutes. Okay, we find that P is the one that releases more steam. Okay, than Q. Q after 5 minutes is still like no steam. Okay, so what is the meaning of heat? Heat is a form of energy. Okay, the simplest definition for heat, okay, is a form of energy. You can, of course, use a more complicated one. I'll talk about heat is energy that gives rise to temperature, yada yada. Okay, but basically, heat is a form of energy. And as I mentioned before, physics is all about the study of different kinds of energies. Okay. Question B1, compare the mass, the heat supplied, and the rise of the temperature of the water. Take a look at the number of marks. Okay, there are 3 marks. So obviously you need to compare 3 things. Okay. So when you compare the mass, remember when you are comparing anything, okay, we always use the words bigger, smaller, or equal to, same as. Okay, whether it's mass lah, the heat supplied lah, the rise in temperature lah. Okay, so we find that P and Q, okay, in diagram 9.1, we find that P and Q have different masses. Okay, and if you look at it logically, Q has a bigger mass than P. Okay, so that would be my first point. Okay, my first point would be Q, okay, fine. The mass of P is smaller than the mass of Q. Okay, please take note now that this is the short form of writing it, but when you answer exam questions, I want it to be in full sentences. Okay, when we discussed the exam paper previously, I also spoke about this. So please take note of this. Okay, the heat supplied will be the same. Okay, the heat supply will be the same, but the rise in temperature, P has a faster rise in temperature than Q, because obviously Q has more mass. Okay, so the rise in temperature of P is bigger than the rise of temperature in Q. Okay, but the heat supplied is equal because they are using the same electric kettle. Identical electric kettles means they have the same power and they are being used for the same amount of time. Okay, second question, state the relationship between mass and the rise of temperature in the water. How do we state the relationship? How do we write the relationship is by using the words, the bigger the something, the bigger the other thing. The bigger the smaller, depending on how the relationship is. So we find over here that mass of P is small, but the rise of temperature is bigger. So we find that the relationship will be the bigger the mass, the smaller the, rise of temperature. There should be a word here, rise of temperature. Okay, we try not to use these words. Mass is inversely proportional with temperature. Okay, usually I would prefer this. The bigger the mass, the smaller the rise in temperature, or the other way around. The smaller the mass, the bigger the rise in temperature. Now, when you write the relationship, stop for a moment and think, does this make sense or not? Don't just write because you know that the answer is the bigger the smaller the, but you need to make sure that it makes sense. Is it true? The bigger the mass of the water, the smaller the rise in temperature. The temperature gets higher slower. Okay, it's definitely true. Okay, number 3, state the physical quantity that must be constant, okay, to deduce the relationship between mass and the rise of the temperature of the water. So what is the physical quantity that must be constant? It is the, specific heat capacity, because both are using water. Okay, specific heat capacity must be constant, okay, so that this relationship works. Okay. All right. So the next part of an essay question is always a 4-mark question. A 4-mark question means it's an explanation question. Now, when the question is 4 marks, okay, then you kind of know that you need to have at least 4 points. Okay, it's okay to write more than 4 points, because sometimes in the answer scheme, then there can be more than 4 points, but they will choose the best 4 to give you the 4 points. So, it's okay to write more than 4 points, but you need to write at least 4 points. So lemonade can be cooled by adding ice cubes into it. Okay, so you have a glass of lemonade, and if you want to make it cooler, you put ice cubes. Give an explanation. How does this relate to specific heat capacity? So mark number 1 is the ice will melt. Okay, ice melts. When ice melts, it will change from solid to liquid. Point number 2, ice will absorb the heat. Heat flows to the ice. So if you have the ice, if you have, let's say I use 1 ice lah. Okay, this is a block of ice. When you put the ice into the water, okay, they are in thermal contact. Remember that? Okay, ice and water, they are in thermal contact. There will be an exchange of heat. But who receives more heat? Okay, it will be the ice. Okay, more heat will go into the ice than the heat that goes out from the ice. Okay, so we say that it is as if the heat flows to the ice. Okay, actually an even better answer, the net heat flow is towards the ice. The ice absorbs the heat from the water, okay, from the lemonade lah. Point number 3, the kinetic energy of the water molecules decrease. Okay, because all the heat is going into the ice is absorbing all the heat. So inside the water, okay, all the kinetic energy of the molecules, okay, they will slow down. Okay, the molecules inside the water will slow down, and because the kinetic energy of the molecules is decreasing, the temperature will decrease. Okay, which brings me to a very important point now when we talk about heat. Okay, why is there an increase in temperature and decrease in temperature? The increase in temperature and decrease in temperature, everything has to do with the kinetic energy of the molecule inside the bahan. Okay, so if let's say your water is boiling, let's say if your water is boiling, inside at the molecular level, all the water molecules are moving very fast. Okay, and that is an indication now of high temperature. If the water molecules are moving very slowly, they're like la 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 la, cool. Okay, that is an indication of low temperature. Okay, and you learn this in chemistry, and it really has something to do with this in physics as well. So think about this, kinetic energy of anything, of water molecules or whatever molecules, always has something to do with its temperature. Something that is very hot, okay, something that's very hot will have high temperature, because anything that is very hot will have high kinetic energy. The molecules are moving with high kinetic energy. That's why the temperature is high. If the temperature is low, it is because the kinetic energy of the molecules has decreased. Okay, so that's the 4 points over there. All right. Sorry, this shouldn't be here. Now, a very common question in section C is this one. You are required to suggest the suitable characteristics of the lidded cup that can maintain the temperature of the hot drink for a long time. Okay, now this is where your creativity comes in, but creativity must come in together with scientific explanation. Don't just be creative, but totally unscientific basis at all. Okay, so the problem with this cup is it's not suitable to maintain the temperature of a hot drink for a long time. It cannot keep the water hot for a long time. So we want to change this cup. Okay, we want to modify this cup so that it can keep the drink hot. Okay, so you look at it in terms of a few characteristics. One is the material of the cup. Okay, and then what is the material of the lid? Okay, and then the method to keep the drink hot. Okay, now bear in mind that we are still in this subtopic of specific heat capacity. So you have to bear in mind that, okay, kalau specific heat capacity means small specific heat capacity means it gets hotter faster and it gets cooler faster. Big heat capacity means it gets hotter slower and it cools down slower also. So you want to choose things that have big heat capacity, okay, so that the temperature in the, so that the water in the cup can remain hot for a longer time. So the first method will be to use a polystyrene material, okay, or to use anything that is a heat insulator. Because what is heat insulator? Heat insulator is anything that is a very poor conductor of heat. susah untuk haba mengalir. Okay, so the reason is to reduce the to reduce the heat conduction, to trap heat, or because polystyrene has high specific heat capacity. Okay, high specific heat capacity means slower to get cold. It takes a very long time to become hot, true. Okay, but it also takes a very long time to become cool. The hot water is already hot. When you put inside now, it is already hot. You want to maintain as long as possible that hotness. So you want to have a material that that keeps the hotter longer. Okay, we don't use tin, tin or metal cups, because metal cups is very good for if you want to cool the drink down faster. Of course, when you pegang dia sangat panas lah, but the drink becomes very cold. Okay. Number two, you want to have a material that has a high melting point. Okay, so these are characteristics lah. Okay, still under this word characteristics. So you have a high melting point so that it is difficult to melt. You don't want you put the hot water inside then okay, the cup changes shape lah, becomes a weird shape. That's why we don't use plastic cup. Okay, I've seen a lot of people do this and it irks me to no end lah. People put hot water in plastic cup. No, please don't. Okay, you put in polystyrene, it's not so bad, but plastic cup, my goodness. Okay, don't. Plastic has a very low melting point and it's very easy to melt. Okay, polystyrene lasts a lot longer. Of course, the most important characteristic is that the material must have high specific heat capacity. Why high specific heat capacity? So that it will become hotter slower. Okay, or so that it will cool down slowly. Okay, point number 7, we want to use a cup that has a white color. Okay, this one that you learned when you were in science form 1. Why do we use cups that is white color? Why do we use permukaan surfaces that are shiny, that are silver color? Okay, because we wanted to reflect the heat. You did this in your PBL as well, remember? Most of you, you line your inside of the oven with an aluminium foil. Why? Because it is a good heat reflector. The heat comes in and it will reflect inside. It will keep the heat trapped inside. Okay. Point number 9, you use a plastic lid. Okay, or you use a lid, a penutup that is either airtight or it is a poor heat conductor, because all the heat is going to come up. Okay, and we want the lid to make sure that it is a poor heat conductor. It insulates the heat so that the heat will continue to dia akan terpantul balik. Okay, so we do this to prevent the heat loss, reduce heat flow, or trap heat. Okay, and then lastly, although it is 10 marks, you can actually give more. Okay, one of the other ways is we cover this whole thing or we wrap it with a cloth. Okay, also for the same reason, to prevent heat loss. Okay, now let me remind you that in questions like this, for 10-mark question, okay, how do we answer this question is we put it in a table form. Okay, so how do we put it in a table form? This is the way. So on the left side over here, so on this side, okay, we put characteristics. Okay, ciri-ciri. Okay, and then this one we will say explanation. This is my standard answering format lah. Okay, our school standard, as I said before, for exam, for 10-mark questions, if you don't give table, automatically 0. Okay, it's automatic, so don't even bother asking for extra marks. So please train yourself to answer in this method. So let's say, for example, you want to put this right. Okay, so then you write cover the cup with cloth. Okay, or wrap the cup with cloth. Okay, and then the reason is to prevent heat loss. Okay, then you tutup. Isn't it so much easier to answer like this? It's so obvious to me, I can read it much easily, rather than you write your grandmother's story once upon a time until the end, one long paragraph to answer this, then I have to go and read your writing, to find for the marks. No lah. Okay, that's why we use table. A table is short, is concise, is straight to the point. No need to talk so many, no need to talk so long. Okay. Of course, 10 marks means you must have 5 characteristics. This is the 5th, and then 5 explanations. Okay, can you give more than 5 characteristics and 5 explanations? Can. Okay, that's why this answer, they give until 6 characteristics. Right? They give 6 characteristics and 6 reasons. All the red color one is reason, all the blue color one is characteristic. It's okay to give more than 5. Okay, of course, you have to have that knowledge with you. Okay, and as I said, now this question is very good because it encourages us to be creative, but not just creative yang yang main tembak saja punya creative lah, but it is actually there's a scientific basis behind that creativity. Okay, next do another one. Let's do another one. Okay, so diagram 9.1, 9.2 show the reading of the thermometer. Take a look at this thermometer reading and this thermometer reading according to this one. Same question, what is the meaning of heat? Heat is a form of energy. We've never run away from this question. Okay, using diagram 9.1, 9.2, compare the readings of both the thermometers. Okay, compare this thermometer. Compare the volume of water and the polystyrene cup. Okay, compare the volume here and volume here. Okay, actually it's in the polystyrene cup, right? Yeah. And the time of heating of water. Okay, notice that both are heated for 5 minutes. Okay, then after that, relate the reading of the thermometer. Relate the reading of thermometer with volume of water. This is one relationship. To make a deduction about another relationship. Okay, so if you haven't realized until now, okay, just now the question and this question is all the same type of question. Okay, not section B anymore, section C. Paper 2, section C. Okay, after the definition, then they will ask you to do comparison and relationship. How do you compare? Something is bigger than something. Bigger than, smaller than, same. How do you write a relationship? The bigger the this one, the smaller the this one. The bigger the this one, the bigger the this one. Okay, so you need to have all this in mind. This is how to answer the question. Okay, I tell you what, it makes life a lot easier because you know what to expect. All you have to do is just make sure that you know how to compare properly. Okay, but half the battle is realizing how to answer, what is the answering technique for this type of question. Okay, so let's start with the first one. Compare the readings of both the thermometers. Look at this thermometer reading and look at this thermometer reading. They're not even asking you to tell me how much. They're just asking you to compare. The height of the black color also you know already. Who has the bigger reading? Obviously is 9.1. Okay, so the thermometer reading in diagram 9.1 is bigger than the thermometer reading in diagram 9.2. This answer is a shortcut answer, but I want you to write your answer in full. Train yourself to write that way. Okay. Secondly, compare the volume of the water. Take a look at this, people. Okay, the only way that you can compare this wrongly is if you are really blind and you cannot see that there's more water in here than here. Okay, so this is a really no-brainer. If you got eyes, you can see, and what you see makes sense to you. Definitely you know that the volume of the water in 9.1 is less than the volume of the water in 9.2. Okay, this one totally got nothing to do with intelligence. You don't have to be like, wow, I cannot do physics because I'm not smart. It's nothing to do with smart or not smart. It's just whether you know how to see or you don't know how to see. Okay, and I believe that all of you know how to see. Okay, so canon. All right. Next, time of heating of the water. We find that the time heating is the same. How you know? Because if you read, you will see that they are both heated for 5 minutes. Okay, another half of the battle, there are many halves okay, of this battle. Another half of the battle is reading the question and understanding what it's saying. Okay, a lot of people will be like, yeah, they never give the time here. How? But actually the time is already given in the question. You just have to open your eyes to see them. Okay, right, let's talk about the relationship. Reading of the thermometer with the volume of water. Volume small, thermometer big. Volume big, thermometer small. Okay, so they are inversely proportional. Or you can say the bigger the reading, the bigger the volume of the water, the smaller the reading of the thermometer. I prefer that answer actually, The bigger the volume of water, the smaller the reading of thermometer. Okay, this also can, but I prefer the way I answer lah. Okay, then so this is 1 mark, this 1 mark, this 1 mark, this 1 mark, all just for comparing and relating. The last relationship is the increase in temperature and the mass of water in the polystyrene cup. So we find that the same thing. Okay, the bigger the mass of the water, the smaller the increase in temperature. Smaller increase in temperature means increase, but increase a little bit, compared to increase, but increase a lot. Okay, so the bigger the mass of the water, the smaller the increase in temperature. Okay, and that will be your 5th mark. Comparing and relating are what we call this one, conceptualizing questions. Conceptualizing. Okay, you're making a concept. Okay, or you are deducing a concept, very important concept. Okay, then once again, a 4-mark explanation question. Okay, sea breeze. Explain how the sea breeze phenomenon occurs during the daytime. Now, this is already inside your notes. Okay, so I'm not going to waste time talking so much about this, but all we know is sea breeze, the breeze comes from where? The breeze comes from here to here, from sea to land. Why is the sea breeze from the sea to the land? Because the land is hot, the sea is cold. Hot air rises, cold air comes in. Hot air rises, cold air comes in. Okay, and then it makes this whole complete circle. So first, land has a lower specific heat capacity. Lower specific heat capacity means what? Get hotter faster. Okay, the land gets hotter faster than the seawater. And so because of that, the hot air above the land rises up and produce a low pressure region. Okay, and then the cold air from the sea moves towards the land. High pressure always moves towards low pressure. Okay, so cold air will go into the land, and that's how the sea breeze is. That's how the sea breeze occurs. Okay, how does the wind from the sea come to you? Because of specific heat capacity. Really, it's because of specific heat capacity. Okay, land gets hotter faster, so the hot air will go up. Okay, and because the hot air go up, low pressure region over here, I'm scribbling until don't know what already. Okay, and then it will go in. Okay, now once again, another modify question. Okay, this is also another 10-mark question, but the good thing is all the 5 characteristics are already given to you. Okay, so very easy, right? So let's say if we do table characteristic. Okay, and then of course sebelah kanan is explanation lah. Okay, remember once again, this question, the 10-mark question, must be answered in table format. Okay, table format. So the first one, the size of the fan used. You are required to modify the car radiator system so that it can cool the engine effectively. So you want to use which size of the fan? Small size or bigger size? Obviously, you want to use a big size fan. Okay, then why? You write here. So again, now remember, please answer this in a table format. Okay, let's look at the answers. So the size of the fan used is a big fan. Okay, why? So that it can suck more air into the radiator. We want this fan to be very big, okay, so that you can, it can cool down. The purpose of the fan is to suck in the air, so that the air can cool down the hot water. Okay, so the more air you can suck in, the more heat is able to be released. Secondly, you want to have a high number of fin blades. Okay, I know the question says number of fin blades, but when you answer questions like this, this is an answering technique. Okay, right now, our fan only has 2 blades, only 1, 2, that's all. So if you want to be able to cool down, you want to suck in more air, right? You need more blades. Okay, more apa itu bilah kipas lah. Okay, so we don't really give the number. We just say high number, big number, or small number. Okay, so we have a high number of fin blades so that it can have a larger surface area. Sorry, Did I? Sorry, this is the fin blade. Ayo. Sorry, this is the fin. Sorry, my mistake. I thought it was a fan blade. It's fin blade, fin blade. Fin blade is here. Okay, the more you have a larger surface area so that you can release more heat. Okay, the material of the fin blade. Okay, the material of the fin blade, you can use metal or copper. Usually these are the best because it has low specific heat capacity. Okay, low specific heat capacity, then you can release heat much easily. Okay. Fourth, specific heat capacity of the cooling liquid should be high. What is the cooling liquid that we usually use inside a radiator? Okay, usually is water lah. Because water has a very high specific heat capacity, it has a high boiling point, so it doesn't evaporate very easily. Okay, but we use a high specific heat capacity. What is the partner for high specific heat capacity? It gets hotter slower. Okay, it heats up slowly or it absorbs more heat. Okay, always the same one. High specific heat capacity heats up slowly. Low specific heat capacity cools down faster, heats up faster, depending on which situation you want. Okay, depending on which situation you want. Boiling point of the cooling liquid use should be high so that it doesn't boil easily. Notice here, we never put number. Okay, although if you remember, the specific capacity of water is actually 4,200 joules per kilogram per degree Celsius. Okay, that's true lah, but we don't put the number. We say high, low, high, low. Okay, don't put the number because there could be a chance that your value is wrong or you forgot the value. Same with the high number of fin blades. Okay, we say high because it is a safe answer. If you write 10 fin blades, okay, but originally there's 100 fin blades over there. You write 10, it's like, because to you 10 is a high number. Okay, maybe to you 10 is a high number, but it's a risky answer. What if your radiator already got 100 inside? You say 10 means it's lower than 100. Okay, no point. Same with our boiling point liquid. We don't give the number, although we know, okay, we know that water is 100 degrees Celsius is the boiling point. But we don't give the number. We just say a high boiling point because the answer is a safe answer. Okay, so again, answer in a table in order to get the full 10 marks. All right, one last question. This is not in section. Oh yes, this is in section B. Sorry, this is section. Is this in section B? Hold on. Oh yeah, this is section B. Okay, this is section B of your paper 2. This one, the section B type of question. So, a metal block over here, then you put inside the polystyrene cup for 30 degrees Celsius. What is the meaning of thermal equilibrium? Thermal equilibrium is when the net heat flow is 0. Okay, and both bodies are in the same temperature. One of the definitions that you really have to remember, 2 important things. Okay, 2 things happen when 2 objects are in thermal equilibrium. Net heat flow is 0, temperature is the same. Okay, so explain in terms of thermal equilibrium how a thermometer which is placed into the boiling water reads a temperature of 100 degrees Celsius. Okay, so this is from the previous subtopic, but we can talk about this in this one also because it has something to do with heat lah. Okay, so point number 1, heat will flow from the hot water into the thermometer. Okay, heat flows from the hot water to the thermometer until it reaches thermal equilibrium. But actually, we know that, okay, let's say this is a thermometer and this is water. Okay, this is water. What is actually happening is there is heat flowing into the thermometer and there is some heat that is flowing from the thermometer into the water. Okay, so actually, we can add another word here. The net heat flow is from the hot water to the thermometer because there's more heat flowing from the hot water to the thermometer than it is the other way around. Okay, but it will continue to flow until it reaches thermal equilibrium. When it reaches thermal equilibrium, we find that the temperature of the water is the same as the temperature shown by the thermometer. Okay, and that's why there will be no net heat flow. So originally there's a net heat flow over here, but once it has reached thermal equilibrium, there is no net heat flow. Okay, the heat that is flowing to the thermometer is the same as the heat that is flowing out of the thermometer. Okay, that is what no net heat flow. Doesn't mean that there's no heat flowing. Totally wrong. Heat always flows. As long as two things are touching, heat will always flow. The only question that you have to ask is whether they are flowing the same rate or whether somebody is providing more heat to the other person or not. Okay, when the heat flow is the same, I transfer to you same as you transfer to me, that is what no net heat flow means. Okay, no net heat flows. Okay, another question in the section B is a calculation question. So calculate the final temperature of the water in the polystyrene cup. In thermal equilibrium, okay, let's take a look. We have the mass of 500 grams, boiling water 100 degrees Celsius. If you remember from the previous one, when this is 100 degrees Celsius, when you transfer, this mass is still 100 degrees Celsius and the heat is flowing out. Okay, transferred into 200 grams of water at 30 degrees Celsius in a polystyrene cup. Is it going to increase? Yes, it's going to increase. Is the temperature in the black, is the temperature over here going to decrease? Yes, it is going to decrease. So this is how we would write this. Okay, this is by M and this is by the water. Okay, 0.5 because it's 500 grams. This is 0.2 because it's 200 grams. The specific heat capacity of M is 800 joules, and the specific capacity of water is 4,200. Now, this is the one that probably will confuse a lot of you. Why is it that one is 100 minus T and the other one is T minus 30? Okay, think about this. So when you put the block inside the water, okay, the block is 100 degrees Celsius. This one is 30. Okay, 30 degrees Celsius. This one is going to be temperature increase. This one is going to be temperature decrease. Okay, until they both reach the same temperature. Okay, if this is confusing to you, pause this video, take a while. Okay, take a while to understand what is going on. Because this one is not one time you see, understand or not, very few people have that kind of, like amazing capability. Like even I also don't. Okay, when I first started this, when I first started learning, okay, about this, I also took some time to understand. Why is it that one is 100 minus T and the other one is T minus 30? This is 100 minus T because this one, the temperature is going to decrease until T. But this one is T minus 30 because it starts from 30 and it's going to increase until the temperature T. Okay, because the basis of this is the heat released by M is the same that is the heat absorbed by the water. Okay, and the temperature increase or decrease cannot be a negative number. Then 100 minus T, positive. If you do T minus 100, then you're going to get a negative number here. Not so good lah. Oh. Okay, this one, temperature is going to increase. So it has to be T minus 30 so that your answer is positive. Okay, and you will calculate, you will get the answer. T equals to 52.58 degrees Celsius. Meaning that this block, okay, it's going to go from 100 and it's going to cool down until become 52.58 degrees Celsius. The water, when you put the block in, it is going to increase from 30 become 52.58. Okay, so be very, very careful. This is what it means. Okay, this is what this 52.5 is. Both of them have the same temperature, thermal equilibrium. Okay, so this is where the combination of thermal equilibrium plus specific heat capacity comes in. Okay, we use this a lot in this calculation question. Okay, state one assumption that you have made. I mentioned this in the previous class. Whenever we talk about heat questions, one very important assumption is that there is no heat loss to the surrounding. Okay, definitely no heat loss to the surrounding. Okay, your homework for today. Okay, your homework for today, which I want you to complete. Actually, if you can complete it now, okay, because this class is 1 hour and this video is actually less than 1 hour. So I want you to answer this question. Okay, this is a section C question, sorry, section B question, which you can still answer in table form. Okay, except that our table form is characteristics Okay, and then over here is explanation lah. Okay, and then the first one, the second one, the third one, the fourth one, and then the final one is this one. Determine the most suitable. So usually I will write, sorry, most suitable, okay, choice is which one? W ka, X ka, Y ka, Z. Because, and then after that you give me the reason. Okay, the reasons is just because, you know, all the characteristics are there. Now, if you don't remember how to do this, okay, go and look back at your old exam paper. Okay, look at how I taught you how to answer this kind of question. This is not a modified question. Now, this is making a decision kind of question. You have 4 different thermos flasks, and every one of these 4 have different characteristics. For example, thermos W has a hollow plastic stopper. There is a space over here, there's a vacuum. This is the double wall tube is made of glass and it is coated by a shiny paint. Thermos flask X has a hollow plastic stopper, okay, has a vacuum over here. Vacuum means there's no air lah. The double wall tube is made of copper and then it is coated by a black paint. Okay, so you have to make choices. Okay, among the stopper, which stopper is good? Hollow plastic ka, solid plastic? Okay, among the space over here, do we want to have vacuum or do we want to have air in this space over here? Okay, among the double wall tube materials, this double wall tube, should we make it by using glass or should we make it by using copper? Okay, if we make using glass, why? If we make using copper, why? Okay, and then the paint over there, do we want to have shiny paint or do we want to have a thermos flask that has a black paint? Okay, one one very important tip I want to give you when you're making all these kind of choices is don't make choices according to what you like. Okay. Okay, don't make choices according to what you like. Sometimes maybe you're in that kind of vibe, right? And then like, oh, I like everything black. Okay, so I want to choose black paint now. Okay, but black may not be the correct answer. Okay, the function of the thermos flask is to maintain the drink temperature, maintain the temperature of a hot drink for a long time. If you coat it by using a black paint, just because you like black paint, does it really serve its purpose? Really, really, if you coat the double wall tube with black paint, means the drink will become hotter longer. Are you sure? Or should we change to shiny paint? Okay, so don't be influenced by what you like or this one, but keep your focus to the purpose of the thermos flask. The purpose is to maintain the temperature of a hot drink for a long time. Okay, once you have made the choices for each of these characteristics, make the most suitable thermos flask. Is it W? Is it X? Is it Y? Or is it Z? Which one is it? And give the reasons for your choice. Okay, why? Why is the thermos flask most suitable? Why is the thermos flask that you choose the most suitable? Okay, so I want you to answer this now. This one shouldn't actually, answering this shouldn't take more than 20 minutes because it's only a 10-mark question. Okay, but I want to see how far you remember about what I have taught you, how to answer these kind of questions. Okay, so send in your answers to the Telegram homework channel. Okay, and I will mark and I will see whether you can score 10 out of 10 or less than 10 out of 10. Okay, so please complete this now and hand it into the Telegram channel before the day is over. Actually, if you can do it now, okay, because you still got some time. Okay, but if you really want to rest, fine, go and rest, but finish it by today. All right, and I'll see you in the next class.